IoT Home Security System Prototype, designed by Hannah Moss. Hello world, my name is Hannah Moss, and I'm going to show you my path into prototyping a security system, and how my projects can benefit your home and business. The purpose of this creation is to make homes and businesses safer, to secure doors and windows by notifying of intruders and how far into the building they are. This system has many uses and is very easily expanded to add other types of sensors to personalize each home or business it's placed in. The focus here is on a system with an operating door sensor, alarm system, distance tracker, and an automatic light, as well as detailing what steps it took to create this system. I'm going to start off this presentation by telling you a little bit about what went into learning how to create this prototype. Now, the picture you see here on this slide is of a sketch done in Arduino IDE. The code is telling the serial monitor to print the words, "Hello World." This is a very simple and effective way to prove that your microcontroller is connected to your computer through the port. The code is written onto the device and then uploaded. You open the serial monitor and it shows you the print, "Hello World." Here you can see some of the prototype designs in Tinkercad. Now, Tinkercad is a program that you can use to build and test designs before building them physically. This is very helpful when it comes to coming up with design ideas. This way, you don't have to have all of the physical components in front of you, but you can still work on your design and find out if it's going to work properly or not. Here in the picture shown, you can see the components required to create this design for this home security system. The inventory required is an Arduino Mega 2560, USB to Type B cable, breadboard, wires, 10K resistors, an active buzzer, various LEDs, an ultrasonic distance sensor, and a photoresistor. Capabilities of what you can build in Tinkercad and with just a few components are limitless. It doesn't take much to start building the circuits either. The photos you see here are the code and physical build of the same Tinkercad design shown previously. The code written in the sketch is telling the Arduino to make the red LED blink at an interval of 1000 milliseconds or every second. In this slide and the next, I'm going to show you how making a simple door alarm is done. In the picture shown, you can see the LEDs that cycle and an active buzzer that goes off depending on the information the sensor is telling the controller. The code for the door alarm is shown in an Arduino IDE sketch found in the top right corner. This code tells the controller to turn on the red and yellow lights as well as the active buzzer when the door has been opened. When the door is shut, the green LED stays lit up, showing that the door is safely sealed. In the bottom right, you can see the sensor information being sent to the controller. The component you see that looks a little bit like two speakers is an ultrasonic sensor. This sensor feeds out an ultrasonic sound and then receives it back. The amount of time it takes for the sensor to receive the sound back indicates the distance traveled. In this circuit, the closer an item is to the sensor, the more intensely the buzzer sounds. The top left photo shows the code for running the actions of the sensor and buzzer. The middle and bottom photos show two separate graphs plotting the distances from the sensors over a given time. The next item in this system is the automatic light. This circuit design utilizes a blue LED and a photoresistor. The photoresistor senses the light level around it and turns the light on and off. The photo of the IDE sketch in the bottom right-hand corner holds the code telling the controller to turn the light on when the photoresistor senses a low light level and to turn it off when the sensor detects higher light levels. The photo along the left shows the sensor data from the Arduino. Often, when building circuits and writing code, it's easy to miss things that seem small but are capable of causing system failures. While building this prototype, I found, after rebuilding numerous times, a broken LED causing my catastrophe. On another occasion, I managed to find that I'd flipped the positive and negative leads on my buzzer. This IoT security system prototype is simple but could easily be developed for more expansive uses. Currently, it only contains a door sensor, alarm system, distance tracker, and an automatic light. Things like flood sensors to prevent water damage, moisture sensors to prevent mold growth, and smart smoke detectors would be amazing additions to this system.